Hi, everyone. Glad you could join us for today's session, Building a Complete Pipeline, the Essential Components of Continuous Testing, with guest speakers Guy Arieli from Experitest and Eran Bar-Lev from Applitools. Before they dive into the session, I want to give a brief intro about our speakers. Guy Arieli is the CTO of Experitest. He has more than 18 years of development and hands-on experience in test automation. Prior to Experitest, Guy held management positions in HP, Cisco, and 3Com, just to name a few. Eran Bar-Lev from Applitools is a senior software engineer and ISTQB certified software tester with over 2 decades of work experience at large enterprises as well as startups. So without any further ado, Guy, the stage is yours.
Hi everyone, and thank you for joining this webinar. My name is Guy, and with me I have Eran. I'm very excited to be here and work with you on all of the everything around building a pipeline and continuous testing. I think this is a very important and exciting subject, and we are going to get into that on both the theory and the slides, as well as a demo. So in the end of the session, we're going to have an in-depth demo, and let's jump into the agenda. So we'll go into continuous testing overview and the value of building a solid pipeline. We are going to focus on 3 essential components: functional testing, which is quite obvious, and we will run through it very quickly. Then how to add performance testing into your pipeline and use your functional testing to augment also performance. Then visual testing, how to add visual testing, what it can simplify in your functional testing. So we are going to touch on that as well. Then we are going to have a live demo, and we will close it in recap and Q&A. So without further ado, let's get started. And the first thing I want to touch on is continuous testing and the value of CI/CD pipeline. And before we jump into the value of continuous testing and what is continuous testing, I want to share with you a statement that I hear from many of the R&D manager that I'm meeting, and what I'm saying is that what they're saying is that quality is the biggest challenge of their organization. So quality is the biggest challenge in most of the technology organization, and this is a huge change. In the past, the main challenges were around the R&D and the scaling and maybe moving into the cloud. But today, most of the technology organization acknowledge that quality is their main challenge, and this is good news for you, because it always good to be, in the center of your or trying to solve your hardest organization problem, and it means that a lot of focus and budget goes into your way, and this is very good. So in general, quality plus velocity is continuous testing, enabling you to increase velocity, keep and grow quality, and make the velocity something that is unlimited, in the sense that okay, if I can release once a day, why can't I release once every hour? Why can't I release once every 10 minutes? And once you have a full continuous testing environment, then the velocity is endless. You can release as fast as you like. And the next essence of continuous testing is fast or immediate feedback to the developers. This is crucial for organization efficiency, and this is maybe the first thing you should think of, how I can provide this feedback as fast as possible. And when I mean fast, I mean 10-15 minutes feedback. Then obviously solid pipeline. This is something that takes time to mature, but this is crucial for continuous testing. Then quality efforts align with big business expectation. Uh, so as a quality engineer, you need to understand your business expectation, and what you are doing, your effort should be aligned with the entire business goals. In the end, what they expected from you is to provide a prioritized list of actionable tasks. Without that, our effort are somehow meaningless, not meaningless, but less efficient in the end. And here, for that, you will need the analytics and other tools. You need to be able to provide a list of tasks that need to be performed in order for the version to be released, and this is also very important. The outcome of that is a huge change in the productivity of your organization, and by doing that, it's not just affecting the quality organization, it has an effect on the entire R&D organization and ops, of course. So that's it, continuous testing. Here I want to show you a small demo. It's not a demo, but just illustration of how a usual pipeline looks like. So we have a Git, we have a Jenkins, we are using Appium, and first we can commit test into the Git repository, and we have developer that commits their code. Whenever a developer perform a push request and merge his code into the master branch, there is a Git hook that trigger the Jenkins and create a build. So the Jenkins will pull the test, it will build the test, and it will also build the application code. And then once the application code is built, it will get uploaded into the cloud, a cloud of devices and browsers, and then the test will be triggered. You want to be able to run your test in parallel, and you want to scale them. Then the next step will be to do a performance and visual validation, and we will show that here in this webinar, and then provide feedback to the developer whether the pull request was successful or not, and if not, it is up to the developer to fix that. So this cycle can take between 5 minutes to 30 minutes, depend on your domain, but when you have that running in scale, this is continuous testing. So we are going to touch on three main subjects: functional, performance, and visual. And the first topic is functional. You are familiar with what is functional, so I'm not going to deep dive into functional. We're going to deep dive into performance and visual. So when we talk about functional testing, we are talking about unit, API, and UI testing. This is the most widespread type of functional testing, and the tools that you will use here are Selenium, Appium, Cypress. You're testing when it's unit testing, you're testing small part of your code, and then it can grow into system testing through the UI, where you are closing big loops around your user activity. And as you already know, functional test is compound out of steps that user will usually will perform, clicking on element, performing login, performing certain operations. So in the demo, we will start with a pipeline that has a functional test, and we will show you how we can add visual and performance testing into that. Now let's touch a little bit about performance. So obviously performance is not just loading the server. So there is a difference between load testing and performance testing. And when I'm talking about performance, usually what I care about is what is my user experience. And user experience, especially in mobile, is more than response time. It's the CPU of the application, the battery, and one of the ways to really increase your user experience and to get a better score in the App Store is to do performance testing and to specifically to do user experience testing. So usually you have this is a generic architecture where when you have a backend, and in the backend you have tools that know how to load the backends with transaction like JMeter and others. But today the main focus is on the client side and the network, and this is mainly due to the cloud capability that we have today, like Kubernetes, when you can scale up and down your infrastructure. So we can see that the bottlenecks moves into the network and into the client side. And this is where we are going to focus today in order to do performance testing, measuring the user experience client side. Now, one more concept I want to share with you is it's called transaction. And when I'm referring to a transaction, usually a transaction will start when a user is clicking on a button or performing any operation on the mobile device. There will be an API request to the server, a REST request to the server. The server will respond, and then the UI will render the response, and the user will see this UI change, and this is a transaction. If you think about your application, usually your application will contain between tens and hundreds of such transactions. And when we talk about performance, we are highly interested in those transactions and how each transaction changes over time and over versions. So here you can see, and I will demonstrate it shortly, how I can record those transactions. So I can either use a manual testing to do that, or I can add it to my automation testing. Those transactions are added into a huge repository of all of my transactions, and I will show that in the demo. Then I have a REST API that enables me to query that and fail my pipeline if I have a regression in one of my transactions. And I also have an analytics and the way to debug my test. So let me run through a quick demo on how to measure manual transaction within my application. So I'm going to open an environment here and find a device. So this is a real mobile device. We will see that when we will execute the pipeline. And you can see here I have a performance tab, and the first thing I'm going to do is install an application. Now this is the application that we are also going to test. What we did is we inserted bug two bugs in version 1.2. One is a performance bug and the other is a visual bug. So now I'm going to measure a transaction. Now the transaction start when I will click on my login button. So before I'm doing that, I'm entering the username and password. I'm starting the recording. You can see that I'm running it in 3G. And this is the recommendation. Once the transaction recording is ready, I'm going to click on that and I'm going to wait for the login screen to finish rendering. Now I can click on stop and I can name my transaction, save it, and view the transaction information. And this is how a transaction looks like. This is the data that is provided with a transaction. So you can see the name of the application, the version, information about the time, the device, and you can see the video recording of the transaction. You can see the duration, speed index, CPU, memory, battery, and network consumption during that transaction. So those are the things that interest your user and affect your user experience. I will talk a little bit about speed index because it's a very important index. And transaction also contain HAR file, and I can view the HAR file, the waterfall view, all the network interaction during that transaction. So here I've performed this recording, and the data entered my database, and it doesn't matter if I record it manually or or from the automation, it will go into the same repository so I can analyze it afterwards. I did want to cover speed index, and speed index is very important metrics when it comes to your application and user experience. When it comes to your application performance and user experience, and here you can see a very insightful example. So we have two websites. Both of them are loading in 5 seconds. So on the top, you can see that during the first 4 seconds, the page is not being loaded, and I can see only 10% of the content. And then in the last second, all of the content appear to the user, opposed to the second example, where after 2 seconds, I can see the frames. After 3 seconds, I can see 90% of the content, and then it jumped to 97 and to 100%. So obviously, from duration perspective, those two example are the same, but for a user, the user experience on the second is much better, and speed index calculate that. This is an image analysis performing on the video and comparing the pixel of the last image in the video to all of the screenshots in between. So when you looking at your user experience performance, speed index, I think today is the most important matrix to follow. This is the HAR file view. It enables you to see all your internal HTTPS requests and to find issues like DNS problems and such. And here you can see how I can analyze in my dashboard. I can analyze my performance, and I will show it live. So I'm not going to focus on that too much at this point. Next, you can see how a performance dashboard looks like. So in the top, you can see different application, whether I have an Android or iOS application. And when I'm selecting an application, I can see all of the different transaction and how they behave, and all of the different metrics and how they behave over version. So here you can see I had a regression and then it was fixed, and now everything is fine. Doing that will enable you to identify issue in a much earlier stages within your testing, and usually performance issues are found in a very late stage, even by your customer in production in many cases. So next, we're going to talk about visual testing, and Eran is going to show you what visual testing is all about, and this is really exciting. So Eran, the stage is yours.
Thank you, Guy. Just tell me when you see my screen. Can you see it, Adi?
Yeah.
Oh, cool. So thanks everyone. I'm Eran Barlev from Applitools, and I'm gonna tie visual testing into the continuous testing that Guy was talking about through Experitest. So if we want to take a step back, let's talk about catching those visual tests. And to be honest here, no QA lead ever walks into the office on Monday morning and says, you know what, this week we're going to focus on catching visual bugs. This is not perceived as priority, but it is happening to everyone, from startups to enterprises. And unfortunately, this hurts not only brand, but also revenue stream. If someone can't click on a button because it's not visible, this translates into a revenue issue that the company is facing. Now, the pressure that we have today on all companies, all sizes of companies, is to release faster. We have to do that to keep up with our customers' needs. We have to do that because our competitors are doing that, and we want to release new cool features to our users constantly. So this is like a never-ending cycle that's becoming the push on it is make it shorter and shorter, and the bottleneck is becoming the QA, and we don't want to become the bottleneck of any feature release. So then we cherry pick what we're going to test. So we end up doing functional testing, and functional testing can be at various layers, and we pick those tests that we can stabilize and run constantly and run efficiently. So it starts at the unit test at the developer station, I would say. It proceeds to the API testing, where we're testing our services that they communicate with each other, and most important is to also cover end-to-end testing. However, even if we test each component separately, it doesn't mean that the end-to-end result is perfect, and that's a headache that we are trying to solve here. So, like Guy was mentioning earlier, functional testing can be performed in many forms and ways. It depends on what we're trying to test. It can emulate the user experience, and it can even test backend functionality through the UI. So it depends on how we want to look at it. But in this example that's in front of us, that's a simple login page that we are required to test. And we'll see that it's not as easy as it's perceived. So here, if I was tasked to test this page, I would probably validate the fields in it. I would validate the error messages. I would validate the text. So here, for example, if someone clicks the sign in button, these error messages should appear required. And this is an example of a test code that will cover that test. Even though it's written in Cypress, you can all probably figure out how to do the same thing in Java, in Python, in Selenium, in Appium. It doesn't matter. It's all the same. Now, if we look at the code here, the majority of the code is actually asserts that we are validating the text is appearing on the button, and on here we see that it appears on the error labels next to the username and password fields. So other than driving the test by navigating to my login page and clicking the sign in button, the rest of the code, which is the majority of it, would actually be asserts, and it's becoming fragile. Now let's see, what do I mean by that? So here, for example, is something changed in the CSS. Some developer pushed an update into our latest version, and we're testing it. Now, this is a visual bug, right? Someone changed the color or the width of the button style, and it's not the end of the world. It's not a functional bug. This is why I said earlier, visual is not always top priority, because this is not a showstopper. However, if this CSS change actually modified the text of the error message, so now it's white over white, this is becoming a functional bug, because the user experience now is horrible. They don't know what's wrong. They just keep on clicking sign in, but they feel like nothing is happening, where actually in reality is an error message is appearing, but it's not visible. And our functional tests will still pass because we are comparing text versus text. So we're checking whether the label says required, and the label actually says required. No one is asking whether it's visible and what's the color contrast on that. So this turns a visual bug into a functional bug. Now let's look at this example. How many asserts do we need to cover all cases on this page? Or this page, for example. It's infinite. There's not enough time and resources in the world that can allow a team that wants to release faster and faster to test that and push to production reliably. So we are kind of in a challenge here. Now, once we find a bug, of course, we have to go and dig into our logs, which is also a nightmare, and find exactly what's going on. So whenever something breaks, we need to report back, and this also is a challenge because we have to give very detailed explanation on what's going on, and sometimes we just don't know. Something just is broken, or it's just visually broken, so it could mean that nothing is wrong in our log files. So dealing with asserts is a maintenance overhead. It means that we need to cover all edge cases on every page, and even this simple page of the sign in has way more issues that can happen there that we can imagine. We just showed a couple of them. So then teams end up asking themselves, is it really worth automating and covering all edge cases? Like I said earlier, cherry picking. So you only test what you imagine might break, but in reality, more things actually break. You can assert non-DOM elements, which is very important, like images or any sorts of graphics or drawings on the page, because these are not assertable. So the fact that an image path is there, the fact that the file name says logo.png doesn't actually mean that it has my logo on it and not an image of a Mickey Mouse, for example. So at the end of the day, everybody's still doing manual testing. You need a human to look at the screenshots or at the pages to make sure that it's all legit. Now let's add AI to the formula here. Now, Applitools is saying, let's continue doing functional testing, but let's do it in a visual way. So instead of all of these asserts that we had earlier, asserting all the text fields, all the labels, everything, replace it with a single line of code, which is check window. Check window behind the scenes will grab a screenshot of the page in front of us and will compare it to the baseline of that screenshot. And by that, we can actually identify bugs that we never thought of. And by doing that, we also eliminate any maintenance of the code, because we don't have to know all the CSS selectors, for example, on the page. So if someone adds tomorrow a new button, a new text field, or removes a field, or adds a menu item, or changes the logo look, or aligns all the buttons to the right, we don't have to change anything in our code. All we have to do is a single click of a button on the dashboard, and we have a new baseline. So we do not, our tests no longer break when the UI changes. And this is very important because that's the reality today. Everything breaks the minute R&D pushes a new version. So you spend a lot of time maintaining and writing new tests for every new feature that comes out. So with visual testing, you need less, I would say, maintenance in terms of the code that you need to write, and you can actually maintain it even without any coding skills. You simply run the test, trigger it from your Jenkins build, like Guy showed earlier, and then you go to the dashboard, accept a new baseline if this is a new feature, or reject it if this is an actual bug and report it back to R&D. We ran a hackathon a couple of months back. We had very, very interesting feedback we got from our participants. So we had about 300 people who completed the hackathon challenge. 100 of them actually won cash prizes, which was pretty cool. The time it took to implement the test itself was 6 times faster. Now, what we're comparing is visual versus functional. Okay, so implementing a visual test was 6 times faster than actually writing a functional test on the pages that we provided. 7.2 times it took faster for the winners, actually. Less lines of code, which is very critical. 72% less lines of code. This means, of course, less maintenance. A number of locators, as you can see, about 10 times more stable for winners. This means that we're not dealing with those flaky selectors when we have to validate them. We don't have to wait for the page, all these waits and sleeps that everybody is adding. We just run the test, grab the screenshots when the page is ready, and we're done. And the bugs found with visual testing, we found 100% of the bugs that were injected into the page versus 70% that functional caught. That's because when you're writing functional, you're only testing what you think might break. Now, in terms of coverage, we can see UI testing on the left here. That is kind of limited when you're doing functional, and it has some gaps. And this is where visual testing kind of overlaps it and adds way more. So you can cover more for less, basically. And this small piece on the left here, that's something that's, those edge cases where it actually makes sense to validate with an API test or a unit test, and you don't need a visual test for that. It can be like testing for a specific unique value that changes every time, and you want to make sure that that unique value appears. If you don't care about the value, Applitools can help you even handle that. So let's jump into the demo, and I'll let Guy drive it for now, and I'll jump in later to go over the Applitools test results when we're done. Guy?
Excellent. So let's go into the exciting part. I hope you can see my screen. Note if you can. Okay, I assume you can. So, okay, great. So what I'm going to do is I have here a Java project, automation project using Gradle, TestNG, and Appium, and I'm going to walk you through the test here. You can see 2 simple tests that I made in advance, and this project is being triggered by a pipeline. So here you can see the pipeline itself. I'm using Jenkins and Blue Ocean. This plugins enables me to build the pipeline and trigger it. And this is how a pipeline usually looks like. So you will see a process of building the application, maybe the mobile application, as well as the server, then a process of deployment, and then running the functional as well as the unit testing, and in the end we do the API checking of the performance and the visual testing. So here we will trigger an API call just to verify that all of the visual tests passed and that all of the performance test passed. Now, those were mocks, so it didn't do a lot, but here we are really triggering Appium tests that are running in parallel. So we are executing around 10 cases in parallel. And here, let me show you how it looks in action. So here you can see those are real devices, and you can see here how all of them are executing my test together. So you can see everyone is installing the application, and now they will go and launch the application and perform all of my functional testing. So this is where I'm starting at. This is this project. This is the two tests that I'm executing. Here you can see the tests are will execute for a few minutes, and this pipeline will run in around 5 minutes. It will execute around 30 test cases, and this is how usually functional testing is done. Now I do want to add performance as well as visual testing into that. So let's take one of the methods here, and here you can see this is the infrastructure that I'm using for driving my application. So I have methods like init. In the init, I will initialize my Appium driver, and then I have a login, and in the login I will add the username and password, and I will click on the login button, and then I will wait for the login to finish, and then I will do assertion to verify that the page is as expected. You can see here that most of my code is assertion. Now let's go on and add visual testing into that. So the first thing I will need to do is open my Gradle file and add the Applitools Java package into my Gradle file, and just import it into my IntelliJ project. So I'm done with that. Now I'm going to add something that call eyes, and this is the object that is responsible for my UI validation. Now inside my init, what I want to do is to open the interaction with the eye, and set the access key and such. So here I'm going to do eyes.open, and I'm going to provide the driver, the Appium driver, as well as maybe the name of my application and the name of my test. So like so, and now the eyes is in it. Now here I want to perform the actual validation. So I'm going to throw out, so those validation are very basic. They just check that the element is displayed. It doesn't check the size, color, anything like that. So I'm very confident on just removing here everything and do a hi eyes.check windows. And here, all I need to do is provide the name of the windows I'm checking. So this will be my main page. And voila, I did visual validation. So you can see how quickly it is to add visual validation into my existing framework. And with a few minutes, I can add visual validation to all of my screen, and I'm ready to go. Next, I'm going to add also performance validation. And in order to add performance validation, what I want to do is mark transaction. So in my code here, you can see I'm adding the username and password, then I'm clicking on the login, and then I'm waiting for the screen to load here. So what I'm going to do here is use ctest start performance transaction before I'm clicking on the login button. And here I need to provide my network condition for that transaction. So I'm going to leave it empty. It will use 3G, which is the default. And now in the end, after I've waited to the page to load, I will do, and performance transaction. And now I need to provide a name for that transaction. So this is the login transaction. So you can see now I have both visual as well as performance added into the login method, and now we can go and trigger our test again. So so I can just push this code into my Git and go and the test will get triggered automatically. I'm going to show you how the results of the performance looks like, and then how the visual results of the visual validation looks like. So as I mentioned earlier, the application that I'm testing 1.2 has both performance as well as visual bugs. And here, when I'm opening my analytics, I have a transaction view, and here you can see I have a 751 transaction that probably I have more as I'm executing my test. More and more transaction are being added. So the first thing I'm going to do is a filter just my login transaction. I'm only interested in login transaction, and maybe just a transaction for Android devices. And now I can group by my application version. And here you can see the interesting thing start. Let me switch here to so you can see how I can view the impact of a change over time. So how my different transaction looks on the version, on different version, and if I have a regression, I can identify it very easily. And if I need, I can drill down into each of those transactions and verify why it took so much time, and I can go and analyze that as well. So this is with regard to performance validation, and the output here will provide me a link into those validations. So if I will open my previous execution and go to either my performance validation, here you can see I can go into a link that will show me these graphs that I've shared with you. So now, Eran, can you show how the visual validation looks like once we executed those tests?
Can you see my screen?
Yes.
Cool. So just to tie to what Guy was just talking about, setting up the test, as we've seen, it's like 3 lines of code, super simple. And to get started, you go to applitools.com, to our tutorials. We can handle web applications, mobile applications, and we also have some codeless tools. But in this example, Guy was using our Appium native Java SDK. And once you added it to your dependencies, it's about 3-4 lines of code. You open the connection to the server, you take a visual validation, as many as you want, just like I did. And when you're done with the test, you call close. Once you call close, the test results end up in our dashboard. And we can see here the first time we ran it, we grabbed a whole bunch of screenshots, both for the login test and the make payment test. And then the first time you run it, it becomes your baseline. Every time afterwards, this is your checkpoint that you want to validate. So so when you're thinking, how do I set up my baselines? We already do that automatically for you. And to override it, because let's say something was funky or you have a new feature that you want to accept, you simply go into the screenshot that you want to accept and you click thumbs up. So this one is automatically accepted because it was the first time, but let's look at the second time. So here we have this test, and I marked it because this is a great example of a past test with Applitools, and we're using an algorithm called layout. But before we talk about layout, let's talk about other tools in the market. So if we look at this as is, we can see that they kind of look the same, right? But if you're trying to validate it with any of the other, I would say, even open source free tools or even paid commercial ones, they're all using a pixel-to-pixel algorithm. And pixel-to-pixel algorithm causes this, a lot of false positives, because if we zoom in and we remove the highlights, it's still hard to see what the machine is seeing. So I'm going to put them one on top of the other, and now I'm going to toggle so it's clear. You see this kind of color change? So this is all it takes to fail a pixel-to-pixel algorithm. So it's kind of pointless. Applitools has multiple AI algorithms that help you validate these kind of screenshots. And let's look at another example here of make payment. Okay, so in this example, we're using again layout, and we can point out, let me put them side by side. So on the left, we see the baseline, how it's supposed to look like, the expected result. And on the right, we see the checkpoint that Guy just ran. And we saw that this is what he injected in version 1.2, where the button is shifted to the left. So this is flagged as a mismatch. Everything that's highlighted in pink is a mismatch. Now, if I'm testing it with exact, of course, a lot of things light up. Even the clock here is lit up. Now, because we're using layout basically understands how the page is built. It's ignoring content, so it doesn't matter the time of the day or the battery level or any other tag that can appear on the page, but it will find structural issues. If you're looking for typos, then you probably need to use strict. Strict is an algorithm that will find anything from a small typo to a missing image, but will ignore those pixel shift that we saw earlier that are causing a lot of false positive and frustration, because then you end up playing with the threshold or the fuzz factor, and it's impossible to get it right. So again, you're dealing with a lot of maintenance overhead. So this is in a nutshell kind of our algorithms. So basically we can handle anything from finding a typo to finding a misaligned button. And obviously here is something, again, we caught this button that's shifted, but the end result was just fine. So at the end of the day, you're just focused on those mismatches, and you go ahead and say, well, this is a bug and this is a bug as well, and you report back to R&D. So this concludes my part of the demo. Guy, do you want to add a few more notes here?
Yeah, so this is brilliant. I'm very impressed, really. So this is what you can see here is it didn't just save us a lot of work in building all those validations. It's also found some issues that we could never validate using a regular functional test. So I think that performing taking your functional, adding it into it both performance and visual, it's something that it's a very small effort and can give you a great value. Next, we are going to conclude and go into answering some of your questions. So, Adi?
Yeah, we do have some questions. So I think the first one is for you, Guy. What is your recommendation for the number of devices to be used as part of our continuous testing pipeline?
Okay, so this is really a tough one. We in Experitest we have different customers that are. It's really depend on your R&D organization and or on your on your velocity. So we have customers that uses 20, 40 devices, and we have our largest customer have between 500 and 700 devices that are running continuously in parallel. So it's really depend on the amount of version that that you want to test. In the end, the important part is that a developer will not wait more than 15 minutes in order to execute their test and get the feedback.
Next question, I think, Eran, this one is for you. It's about functional testing versus visual testing. So someone is asking, visual testing cannot verify whether DOM elements are clickable, editable, enabled. Such assertions cannot be eliminated. Is that correct?
So we have customers that are validating URLs by simply navigating to them. So if you click on a URL and navigate to it, we'll take a screenshot of where you landed at, and this validates that not only it's clickable, but it actually gets to the right address. So it's basically changing the way you look at functional, right? Think, how would you tell a person to test that functionally? So you would tell them, well, try to click on the text box and enter text. Is it editable? So if you look at it in a visual way, then you simply find that element, send keys to it, and take a screenshot. If the keys are there, this means that it's editable. I hope this answered your questions.
Next question for Guy. Does Experitest govern all testing, including the visual testing with Applitools?
Yes, so we recently launched a full integration with Applitools, and we have it as a built-in integration within the Experitest solution.
And the next question is also for Guy. Can we use these SDKs to test embedded platforms? And if yes, if you could elaborate a little bit on that.
So I'm not sure what the question refer with embedded platform. It's mainly for mobile and web application, either running on your mobile or on your desktop devices. So in general, it addresses a digital application, mobile as well as web.
Next question for Eran. How does the tests know what the main page is, what you're comparing to?
Very good question. So you're in control of the test. A part of our SDKs is the ability to grab anything from check element to check full page screenshot. So if you have a very long page that requires scrolling, we will do the scrolling and stitching for you, and to make it into a one long screenshot. So basically you can check one box by calling check element, you can check an iframe, you can check a region by using X, Y, height and width, and of course a full page. So you're in control of the test, basically.
Next question for Guy. Why is it important to integrate UX performance testing as part of functional testing?
First of all, it's easy. It's something that if you have already functional testing, it will not take you much. You don't need to be performance engineer in order to identify performance problem in an early stages of your pipeline. And usually the problem with performance issues is that they are found in a very late stages, either in staging or in production. And here you have an opportunity to actually test your user experience in a much earlier stage in your pipeline, and this is very important.
Okay, next question for Eran. Can Applitools work with native mobile apps, or is it just for web?
No, absolutely. I mean, the demo that Guy was showing, I'm pretty sure it was native, correct, Guy? Am I correct? Yeah. We can handle native, mobile. At the end of the day, Applitools will compare screenshots. So it doesn't matter where it's coming from a web application, from a native application, even upload a PDF. We're in the business of comparing those screenshots using AI.
So unfortunately, that's all the time that we have for today. I do want to thank you for joining us for this live session. And of course, I want to thank our expert guest speakers, Guy Arieli from Experitest and Eran Bar-Lev from Applitools. Before they will say their goodbyes, I just want to remind you that a link to the recording of the session will be emailed to you by end of day Friday. And I do hope to see you all at our next event.
So thank you everyone. And after we end this session, you will get a question. Both Experitest and Applitools has an amazing solution architect. And in the end of the webinar, there will be 2 questions for you: whether you want to meet the Applitools and whether you want to meet the Experitest architect. I really encourage you to provide your details, so those amazing guys will be able to meet with you, hear from you about your challenges, and be able to work with you with insightful and assistant help on your challenges. So add your information, and we will be able to meet live talking about your challenges.
Thanks, Guy. It's always a pleasure. And thank you everyone for joining us today. Have a good one.
Thank you.